Hello and welcome to another episode of AI Buzz. My name is Nick. Thank you so much for tuning in today. I have some great stories out of the world of artificial intelligence and machine learning to share with you. This is kind of a twofer. They're both really cool stories that perhaps don't have quite enough to stand on their own as a full episode, but they need to be shared. They're really, really cool. Let's get started. So mapping software is a tremendous help to everyone. To find out where to go, we heavily will rely on GPS to tell us the optimal routes. In the last few years, the technology has improved significantly. Now the tech can pretty much tell us where the nearest gas station is or where we can stop to eat. However, artificial intelligence promises to enhance the available features further and can provide information in areas that aren't available to the so-called street view cars that generated previous data. A collaboration between MIT and the Qatar Computing Research Institute is working on utilizing satellite images to label road features that will further help improving the GPS programs that we use today. For example, identification of lane counts could help a GPS warn drivers that a lane has merged or closed. Most of this work traditionally has been done by very large tech companies, primarily Google. This research, instead of collecting data from a fleet of cars equipped with these 360-degree view cameras, the researchers are turning to these satellite images to predict numbers of lanes behind obstructions. One of the motivations for developing the technology is to really spread the wealth of information available in large cities onto smaller cities. Typically, the most extensive digital maps of areas are in the densest, most populous locations. The researchers believe that cities large and small should have access to this mapping detail. So the researchers have developed this pilot program they called Road Tagger, and in the testing phase of Road Tagger, the software has already shown tremendous accuracy. Taking 20 maps of U.S. cities, the program was able to predict with 77% accuracy the number of lanes that a road had. Additionally, it was able to identify road type with 93% accuracy. And what they mean there is the road paved or not, I believe. Technology under the hood consists of some really cool technologies. A convolutional neural network in order to analyze the image data, combined with a graph neural network which works to find relationships between different points on a generated graph. So the input to the convolutional network are raw satellite images of cities. Then the graph neural network splits this image into tiled segments that allow the network to fabricate a graph for further analysis by the convolutional neural network. It's really cool that these two networks kind of work in conjunction with this program. When there's a blocked view of a road, the model utilizes the trained relationships to identify what is likely behind the obstruction. The group plans to leverage this technology further in order to predict available parking spaces or bike lanes in the future. The use of GPS is something that the modern world has really come to rely on, and the enrichment of this data with external data coming from satellites through this work between MIT and Qatar Computing Research Institute is really great. It's going to give us a more detailed picture of our world with which to make decisions. This tech is going to enable new countries, perhaps ones that have been sort of ignored or neglected by the huge tech companies. It's going to give them the same information that's traditionally available only to bigger cities and perhaps more favored countries. Moving on now to another really cool story that everyone should know about. In the industrial world, many have realized that artificial intelligence is really great at spotting the patterns of a piece of equipment going downhill. Identifying these cases and deploying the proper expertise to the field to fix the problem before something compounds is really vital. It's important for safety reasons as well as financial reasons of the company. Efficiently being able to identify and proactively fix a problem before it causes the company a massive loss is really important. And if you think about it, this is exactly what machine learning does best, sifting through reams of performance data and identifying what doesn't look quite right. Devastating forest fires ended up being the result of faulty electrical transformers that ignited the surrounding forest in California. So not identifying problems and fixing them can really wreak havoc on the world. And traditionally, technicians are employed to monitor different aspects of a power plant, for example, which includes the transformers, and ensure nothing can cause a scenario such as this. A problem with a transformer can really be devastating, not from a safety perspective, but it could cause the plant to go black and not provide power or money to the company. General Electric's one of the leaders in providing industrial equipment for a range of applications, such as wind turbines, gas turbines, jet turbines, the list goes on. One thing that GE really does a great job of is combining these packages with their equipment. They provide a predictive maintenance package that tries to sort of look for these anomalies before they happen, and then they can deploy a technician to the field. Perhaps an even more innovative and fresh approach is coming out of a startup from two MIT graduates, John Garrity and Will Vega Brown. They're working to revolutionize the maintenance of industrial equipment. They aim to make the machines that power the world more efficient and safer using analytics and machine learning. While at General Electric, John Garrity, one of the founders, noticed that improved energy monitoring models could greatly improve the reliability and profits of some of GE's packages. So TagUp, which is their company, leverages the availability of sensing data with these machines to make the engineers that review the data much more efficient. One example of their new TagUp technology directly detecting failure in a plant is actually in a power plant near MIT. It's a power plant on the Charles River. The plant manager called Garrity about one of the transformers that appeared to have gone offline without any warning whatsoever. With their real-time analytics application, Garrity was able to provide information to the plant manager that allowed the transformer to get back up and running as soon as possible. The team estimated that this saved the power plant approximately 26 hours of downtime and about $150,000 in revenue. Overall, identification of transformer failures are a huge industry, which end up costing $26 billion to organizations around the world by one estimate. Not to mention the huge safety concerns of finding and fixing these types of failures before they become catastrophic. The duo, Garrity and Vega Brown, aim to move towards more optimization of industrial machines. They wish to really cut down on waste of power and water while simultaneously making the industrial machines more safe. The Internet of Things provides a vast amount of data from industrial equipment as well as consumer electronics. Leveraging this data to its fullest to detect inefficiencies as well as safety hazards can spawn many new businesses and industries. Bringing humans into the equation to manually review the most sensitive and troublesome areas will result in quicker decisions that are made, and will result in overall safer operations of these industrial machines. The alternative is having humans manually be involved in this monitoring process, and while at first it might seem ideal, it's very prone to error and results in really low efficiency for companies. So turning to automation like the company TagUp is doing is certainly the way forward. Thank you so much for tuning in today to this doubleheader of an episode. This has been AI Buzz. I'm your host, Nick. I'll be back very, very soon with more stories out of the world of artificial intelligence and machine learning. Thanks for tuning in. Have a great day. Bye.